This is problem 20 from chapter 14. The crash cushion for a highway barrier consists of a nest of barrels filled with an impact-absorbing material. The barrier stopping force is measured versus the vehicle penetration into the barrier. Determine the distance a car having a weight of 4,000 pounds will penetrate the barrier if it is originally traveling at 55 feet per second when it strikes the first barrel. So we're using the relationship that we have here, and I have an initial kinetic energy, and in this case the height of the car should not be changing. So we can ignore gravitational potential energy, and there are no springs. So that leaves me with 1/2 mv1 squared, which is the initial kinetic energy, plus the work done, is equal to the final kinetic energy, except that when it stops penetrating the barrier, the speed would be 0. So this is just 0. Let's see. I know the weight of the car. I want the mass of the car, so I can say this is 1/2 times the mass would be 4,000 pounds divided by 32.2 feet per second squared, and V1 is equal to 55. And that is, let me just write it like this. So this is 1/2 mv1 squared, which is equal to this, and that is equal to 187,888. And let's take a look at the units. We had pounds divided by feet per second squared times the speed squared, so that would be feet squared per second squared. So that and that cancel out. This cancels with one of those, and that leaves us with foot-pounds. Okay, so those are the units that we have for energy here. Then let's take a look at the force that you would have acting on the car. So here's our car going into the barrier. It's moving this way, but the barrier would exert a force acting in the opposite direction. So F dotted with dr is negative F. And they said the magnitude of dr was ds, so we'll call that minus F ds. So the work is going to be negative, and we can bring that to the other side of the equation and then say the initial kinetic energy is equal to F, with the integral sign. Okay, so I have a graph here of the force versus vehicle penetration. So that would be the force on the y-axis, ds on the x-axis. So this integral is just the area under the curve. I want the area underneath the curve, I should say from 0 to s. I want the area under the curve to be this value here. And when I reach that value, that is when the speed is equal to 0 and the vehicle stops penetrating into the barrier. So I'm going to start adding up the area that I have underneath, and I stop when I get to 187,888. Okay, so this is the area, and so now I'm going to calculate what that area would be. Okay, so we're going to go to, that looks like 2 feet there, and find the area for this first part of the graph. So that's 2 feet times 9. This is kilopounds. So maybe I just want to call that 9,000 pounds. So that is 18,000 foot-pounds, which is less than 187,888. So then I keep going. So now I'm at 5 here, so the distance from here to here would be 3. Maybe I should just draw what I'm doing here. Okay, so that area was 18,000. This was from 0 to 2. Now I go to 5, so from here to here is 3, and the height that I have here is 18. So this is 3 feet times 18,000. And that is 54,000. Well, 54 is less than 187,888, but the total area when I get to 5 feet would be this area plus this area plus this area. So now I'm at 54,000 plus 18,000, which is 72,000, which is less than 187,000, so I keep going. So for the next piece, that goes up to 10. So this distance is 5, and that is at a height of, oh no, it keeps going. Okay, so that goes up to 15. So that width is 10 from 5 to 15, and the height is 27. So this would be 10 times 27,000, which is 720,000, which is more than 187,888. So the vehicle doesn't make it to 15 feet. So to figure out how far it makes it, well, let's say that would be something like this. This is the distance that I'm looking for. And this total area should be equal to 187,888. And I already have 54,000. So it's 54,000 plus the height of 27,000 plus, let's just say for now, this distance x, and then use that to find the distance that we want. So 27,000 times x. So x is equal to 187,888 minus 54,000, which is 115,888 divided by 27,000, which is 4.292, but that was just this distance here, so I have to add that to this distance, which is 5. So my answer is 4.292 plus 5, which is 9.292. So the vehicle penetrates 9.292 feet. And that concludes problem 20.